This is a brief demonstration of the NanoXtract tool for nanoparticles image analysis developed by NovaMechanics. The aim of NanoXtract is to analyze TEM microscopy images depicting nanoparticles and to extract useful descriptors that can be used in a future step as inputs to toxicity prediction models. The tool is freely available and can be accessed online through the presented link. To initiate the image analysis, the user must upload a TEM image in PNG or TIFF format. By clicking on the Upload button, a pop-up file upload window appears, and the user can browse and select the photo of interest. The user must select from the NP type drop-down menu the type of the depicted particles in the uploaded image. The available nanoparticle types are circular, cylindrical, and plates. If the particles do not fall into the previous categories, the user can select the category Other. By clicking the Activate Capture checkbox, the user can draw a line and measure the scale bar in pixels. Then the user should type the known distance of the ruler in nanometers, in the measured length field. In the line length field, the measurement of the line in pixels will be displayed, and the scale ratio will be displayed in pixels per nanometers ratio field. This step is important in order that the calculated descriptors, such as the diameter, to be displayed in the proper units. After the scaling measurement, the user should uncheck the Activate Capture box, in order to proceed with the further steps of the analysis. After the initial steps, the image descriptors are ready to be calculated, by clicking on the Computation button. The default tool parameters are applied for the image analysis. For each segment of the final stage, 16 image descriptors are calculated. By clicking on Descriptors Mean Values button, the user can download a CSV file containing the mean descriptor values and their standard deviation. By clicking on Descriptors Per Component button, the user can download a CSV file containing the calculated descriptors for each particle. Detailed information about the calculated descriptors can be found in the NanoXtract tutorial in the top ribbon of the web service. Now we are going to demonstrate two simple case studies where a parameters tuning is required for satisfactory segmentation and labeling of the nanoparticles. The sample we are going to analyze is IO166D gold 12 nanometers PEG-ohm. As you can see in the uploaded TEM picture, circular nanoparticles are depicted. We are going to execute the app with the default parameters. As we can see, the segmentation is unsatisfactory, and no results are produced. The error message that appears on the screen informs the user to change the filtering parameters. As we can see, the main problem is occurred to the thresholding step. Now we are going to tune the parameters and we will execute again the web service. Information about the tuning parameters and their exact impact on the analysis can be found in the tutorial. Now the image is properly analyzed, and calculation of descriptors is achieved. In the last step, by clicking on Automatically Remove Outliers box, the results of the statistical filtering are displayed. The statistical filtering is performed in order to exclude the outliers of each descriptor and recalculate the mean descriptor values. We can download again the mean values of the descriptors and the descriptor values for all samples. We are going to keep the file containing the values of descriptors for all particles, for later use in a prediction scheme. Our final case study is the analysis of nanorods. We have to select from the drop-down menu as nanoparticle type the cylindrical and then adjust the parameters as in the previous case study. The noise reduction is an important step, especially when the analyzed image is of low quality. This step applies a Gaussian blur in order to reduce image detail. The x and y dimension sigma values determine the effect of the blurring. In the thresholding step, the grayscale TEM image is converted to a binary one by defining a grayscale cutoff limit. Grayscale values below the threshold are converted to black and those above become white. We can select an automatic threshold method from the drop-down menu of the method field. In case that manual method is selected, we should provide a threshold value. In case of unseparated segments, we can improve the quality of the extracted labeling. Distance merge threshold controls the proximity of the segments that will be merged, gauge size controls the extent of the splitting, whereas size merge threshold controls the minimum size of segments that will be merged regardless of their shape. When satisfactory segmentation is achieved, the labels are filtered based on their size. We can adjust the filtering levels in order to remove outlier labels. In this example, only one particle passed the applied filters, and thus standard deviation is equal to 0. Now we are going to use the calculated descriptors in a real-life application, using the nanoinformatics model for zeta potential prediction powered by Enalos Cloud platform. The model can be accessed as a web service through the presented link. To use the model, the values of 3 variables must be provided: the type of the nanoparticle's core, the pH of the solution where the experimental measurement of the zeta potential would have been made, and the value of the main elongation of the particles. For one or for a set of particles, all necessary information can be submitted via a CSV file, by clicking the Upload CSV file button. The file must have a specific format as in the template file that is available to download. We are going to predict the zeta potential of the 49 nanoparticles analyzed in the first case study, so we have to prepare an acceptable CSV file. The type of core is metal and the pH of interest 6.5. In the downloaded file with all descriptors, we have to keep only the column named main elongation. We also have to add the columns with the type of core and the pH, according to the template. The column names must be in accordance to the template as well. Now we are ready to upload our file to the web service and acquire the zeta potential predictions. A table is presented with the produced results. The predicted zeta potential column contains the zeta potential prediction in millivolts of each submitted particle, based on the predictive model. The domain column contains an indication on the reliability of predictions based on the model's domain of applicability limits. By clicking the Download Files button, the table is downloaded in CSV format.